This is what you call a traditional water meter. And this is a clamp-on ultrasonic meter, and it's basically a water meter too. Coming up next, a tech review of ultrasonic water meters. Welcome to Instrumentsdirect. And on today's tech review, we're going to learn all about clamp-on ultrasonic water meters. So, how does it work? The transit time technology works by clamping transducers on the outside of a pipe. As you can see, we have two different configurations. Basically, the way that this works is the flow going from the left to the right. The transducer on the left sends a sound burst across the pipe to the transducer on the other side to measure how long it took to get from the first transducer to the second transducer, or the transit time. So, at the same time, the second transducer sends a sound burst back across the pipe to the first transducer, and because it's going against the current, it takes a longer period of time, again, or transit time. So the faster the flow rate, the greater the differential, or the transit time between the two transducers. This differential transit time is the coefficient we use to calculate volumetric flow, or example, GPM, gallons per minute. Unlike an ultrasonic Doppler flow meter that reflects off of suspended particles, the ultrasonic transit time requires no solids at all, no suspended solids, and it works in perfectly clean liquids. The clamp-on mounting configuration traditionally uses the dual path, or the V configuration, for pipe sizes 2 inches to 24 inches, or single path. The Z configuration for larger pipe sizes, typically 24 inches and larger, or in some cases smaller pipes, for poor pipe wall conditions. Now, the math calculations that actually come up with these flow rates are quite in-depth, but with today's technology, most of the programming questions are simple from a drop-down menu system and very, very easy to use. Okay, so you can see the novelty of a clamp-on ultrasonic flow meter is that it measures flow from the outside of a pipe. Not too bad. No cutting pipe, no drilling holes, and no dewatering or shutdown of your hydronic water system. All you do is clamp it onto the pipe and measure flow. So, where do you use it? Here are a few typical applications, and yes, the majority of them will be water. But water is used in many different aspects of monitoring, such as inventory and process control. And here's some typical applications like HVAC, energy applications are very popular for, say, chilled water, hot water, boiler feed. Chemical processes, so again, you can see it doesn't actually have to be water, but it's a liquid application. So as long as you don't have a massive amount of suspended solids or aeration, it's typically a good application for a transit time flow meter to work on. The basic operation of an ultrasonic transit time flow meter is ultra pure liquids up to about 2% suspended solids. And an example would be, say, DI water, sewage, but not sludge or oatmeal. Needless to say, water and wastewater are very popular applications as beverages, power generation, and the list goes on and on. Depending on your application, you may need to use either a portable or a dedicated ultrasonic flow meter. Now, let's check out the features. The NCM series comes in small die-cast aluminum enclosure that has an LCD display of rate and total. It's wall-mounted enclosure, and you also need a set of strap-on transducers. The transducers for 2-inch and larger are adjustable for different pipe sizes. The DTTN is a 1 megahertz used on pipe sizes 2 inches up to 36 inches, sometimes larger depending on pipe conditions. The DTTL is a 0.5 megahertz, traditionally used in pipe sizes 36 inches and larger, or for smaller pipes that have poor pipe wall conditions. Now, the small pipe sensor, the DTTS, are for pipe sizes 0.5 to 2 inches and are not adjustable. They are pipe size specific and material specific. The sensor diameter and crystal spacing is prefixed. So as you can see, it comes in a whole bunch of different sizes, and this makes the installation of the small pipe sensor very simply. You just open up the two parts and clamp it together, and you're all set to go. No spacing adjustments required. Now the meter comes in two basic models. The NCMB, which is the basic water meter, which offers local display and has standard outputs of 4 to 20 milliamp and Modbus RTU. The optional advanced communication models include communications of Ethernet, BACnet, the variations of BACnet, TCP/IP, and more. The energy module, which is the NCME, is a water meter plus the energy module, which allows you to read in BTU. So is it hard to set up this kind of flow meter? The answer is no, even I can do it. All you need is some basic application data, such as the pipe material, the pipe OD, the pipe ID, or wall thickness, and the type of liquids, in which in most cases is water. With this information, we can program the NCM model by using the keypad. And if you lose your way and you don't read any of that installation material, as you can see from this flow chart, it's pretty easy just to scroll through the options, and you can basically walk through each step without any difficulty. For the user with a shirt pocket full of pens and pencils, it comes with a 200-page manual, just what you're looking for. But for the rest of us who don't even have any shirt pockets, it comes with a 1-page quick start and a link to a simple training video. Now, if you want to get fancy, you can also use a laptop or a computer to do a basic setup. You can also do the basic setup using this laptop, and you can also check out the upper level of diagnostics or set it up for an energy or BTU application, providing you have the energy option. This is accomplished by combining flow and temperature. The flow transducer is typically on the supply line, and they strap on the RTDs, one on the supply line and strap one on the RTD on the return line. And the quest is to monitor temperature differential between the supply and the return line with a non-invasive temperature sensor. Pretty neat, huh? One of the key reasons you need a flow meter is to get the values for some type of control or inventory. So you can just look at the display for flow rate and total and be satisfied. Or if you need to communicate with it remotely, you or your control room or building automation system, you may need to consider some of the communication options. In this case there, even get fancy, you can tie in a radio system should you need to go wirelessly. So, in summary, this fancy clamp on the outside of the pipe ultrasonic flow meter is just another type of water meter and might just be what you're looking for. Thank you for watching our program today. For more information on today's subject, check out our show notes listed below and links. As always, we would appreciate your comments or suggestions of technology or products for our tech review program. This has been Brent Baird for Instrumentsdirect. See you next time.